A, we talked about how pure substances can be divided into two groups, elements and compounds. And so that's what the rest of the pit stops are going to focus on for stop number 1. On page 2, in this pit stop, we're going to talk about elements. So I'm right behind the page you just did, the pure substance versus mixture. Our title on page 2 is going to be elements. Okay. And then the next stop, that will get into compounds on page 3. Okay. So when we said that all matter can be divided either into the pure substance or the mixture, right? So we're still talking about all types of matter, and all matter is made up of atoms. Atoms are something that we cannot see, right? We can't even see atoms under a microscope. They're very, 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 very small, but that's what makes up all matter, including elements and compounds. Elements are the most simple. They're made of only one type of atom. Made of one type of atom. Okay, so the key word here is one. It's going to be the most simple of the two out of the elements and the compounds. Elements, we find elements on the periodic table, which you will become more familiar with over the week. And on the periodic table, you'll probably recognize elements like hydrogen, carbon, oxygen, nitrogen. Okay, and then there's going to be plenty that you haven't even heard of. But every single element, it always has the same properties. So if you have one hydrogen atom in water and you have another hydrogen atom in, say, a gas form, they're going to have the same properties. They're going to be definite and consistent. So I'm going to write that here. The properties are definite. That means that they don't change, right? And consistent. Or another way to think about that is they are the same. Okay. I mentioned earlier that elements are more simple than compounds, and because of that, they cannot be broken down anymore. They are the most simple substance that we have. So we're going to say that they cannot be broken down into simpler substances. Okay. So the element is going to be as simple as it gets. It cannot be broken down anymore. I mentioned earlier that elements are found on the periodic table. Okay, and you'll get a chance to look at the periodic table at the teacher station if you haven't already. And each element has its own little box or square on the periodic table. And each element is also represented by a chemical symbol. Okay, so you might see on the periodic table, you might see H representing hydrogen. Okay, so we're going to say that they are represented by individual chemical symbols on the periodic table. I'm going to underline chemical symbol. Okay, that's something that we always need to associate with elements. Okay, the example I used was H for hydrogen. Right? Typically, the symbol is just one or two letters. Okay, and the first letter is always capitalized. So it's a capital H. Or for example, helium, it's two letters, but it's a capital H and a lowercase e. So that would be He. Oftentimes we use models to represent elements and the atoms of elements since we can't see them, right? We said that the atoms of elements are too small to view with just our eyes. So down here on the rest of the page, we're going to use to draw some examples. Some of them we're going to do in the notes right now, and then others you're going to do at the teacher station over the next few days. Okay. So, for example, hydrogen is a element, okay, hydrogen. It's represented by the symbol capital H, okay? And if we were going to draw a representation of this element, remember it's just one type of atom, right? And each element has its own kind of atom. So this is going to be my hydrogen atom. I'm going to label it with an H, and I'm also going to use green to represent hydrogen in our example models. Okay, so if you have a green colored pencil, you can go ahead and color that in. Another example of an element is iron. Okay. You might know the metal iron. Okay. The chemical symbol for iron is capital F lowercase e. It doesn't always match the first letter of the element name. The F actually stands for the Latin word for iron, ferrous, so that's where it gets the Fe. Okay. Now if we were going to represent iron in a model, we would have to have a different atom. Okay, so this is going to be my atom of iron, and I'm going to use red to represent that. The very first thing we wrote down on this page said that elements are made of one type of atom. Sometimes two atoms can combine, but if they're the same type of atom, it's still considered an element. For example, if we have oxygen, and we should all be familiar, probably heard of oxygen. If we have oxygen, oxygen is actually O2. Okay, notice that the 2 kind of goes at the bottom. That means that there are 2 oxygen atoms bonded together to create that element. So we have one oxygen atom connected to another oxygen atom. Okay, and I'll use an O for oxygen, and I'll use blue to color that one in. So even though there are 2 atoms, because they are the same type, they're both oxygen atoms. Right now we're representing them with a blue color. That's still considered to be an element. Leave some space at the bottom of the page. At the teacher station, you're going to draw some more examples. Okay, so be sure you have a few extra lines for that.